Imagine a world completely silent except for the sound of waves and wind. Around 400 million years ago, Earth's continents were barren landscapes of rock and soil, with no trees, no birds, and no scurrying animals. All complex life was confined to the oceans, which were teeming with diverse fish, armor-plated predators, and thriving marine ecosystems. But the edge of the water was about to become the most important frontier in evolutionary history. Moving onto land wasn't a sudden, heroic leap. It was a slow, multi-generational process driven by survival. For millions of years, shallow coastal waters and tidal zones were crowded and dangerous. Large predatory fish hunted smaller species relentlessly. At the same time, the retreating tides occasionally trapped animals in isolated pools with declining oxygen levels. Small, shallow water fish needed a way to survive these harsh, low-oxygen environments, prompting the gradual development of specialized traits. One of the key evolutionary stepping stones was the development of primitive lungs. Some fish living in stagnant waters began swallowing air at the surface, absorbing oxygen through modified tissues in their digestive tracts or early lung structures. Alongside this atmospheric breathing, certain fish evolved robust, muscular fins with internal bone arrangements that closely resembled limbs. These sturdy fins allowed them to prop themselves up in the shallows and navigate through dense, underwater vegetation. Scientists have discovered remarkable fossils that bridge the gap between water and land. A famous example is Tiktaalik, a fossil organism dating back roughly 375 million years. Tiktaalik possessed a mix of fish-like scales and gills, but it also had a flat head with eyes on top, a mobile neck, and sturdy fin bones that functioned much like wrists. While Tiktaalik likely spent most of its life in the water, it could support its own weight to lift its head above the surface. True land locomotion required even more drastic skeletal shifts. Later creatures, such as Acanthostega and Ichthyostega, developed distinct digits on their limbs, though they still retained tails adapted for swimming. These early tetrapods, meaning four-legged vertebrates, gradually improved their ability to support their bodies against the pull of gravity, a force that underwater animals rarely had to contend with. Their hips and shoulders grew stronger to anchor their new limbs. It is important to note that vertebrates were not actually the very first creatures to touch dry land. Simple plants, fungi, and small invertebrates like early millipedes, flightless insects, and arachnids had already begun colonizing the moist edges of the continents millions of years earlier. These pioneering invertebrates provided a crucial, untapped food source that likely drew the first adventurous vertebrates further away from the water's edge. Over tens of millions of years, these tentative excursions transformed early tetrapods into fully terrestrial animals. They developed tougher skin to prevent dehydration and evolved eggs that could survive outside of water. The descendants of these pioneering creatures would eventually diversify into all the amphibians, reptiles, birds, and mammals we know today, forever altering the surface of our planet.